Hi, and welcome to Algebra Examples. My name is Dr. Finch. Today we're going to look at an example where we're looking for all polynomials of degree less than or equal to 2 that satisfy certain conditions. So when we look at our conditions here, we notice that when we plug in 0 or the number 1, we have to get 1 as an output. And when we plug in 2, we must get 2 as an output. All right, let's get started. We know that our polynomial is of degree less than or equal to 2. So if we remember correctly, our polynomials always have the form of ax squared plus bx plus c. Now our polynomials could get bigger, but as we saw, we have degree is less than 2 or equal to 2, and our degree is our exponent, the highest exponent in our polynomial. So the highest exponent we can have is 2. So that means this is the start of what we're looking for. When it says find all polynomials, we can rewrite that. We want to find A, B, and C. So we want to know what those numbers are in order to make our polynomial have those outputs that we're looking for, these constraints. So let's start off with our first constraint. P of 0 is equal to 1. All right, so when we plug in 0 for our x, we get a times 0 squared plus b times 0 plus c, which means everything cancels out except for our c. We know that p of 0 is 1, so we have c is equal to 1. All right, that's great. We've got one variable down. We know that one of our coefficients, our c value here, is equal to 1. Let's see what happens when we plug 1 into our polynomial. So our polynomial now, when we plug in 1, we are going to get a times 1 squared plus b times 1 plus, and now I'm going to put a 1 in for our c value since we already know it has to be 1. So this is going to give us a plus b plus 1. We know that has to be equal to 1. Let's subtract 1 on both sides. We'll clean this up just a little bit. We get a plus b is equal to 0. I'm just going to kind of pop it over here. That means a is the same as negative b. So we have this relationship between a and b that we already know about now. And that's not going to be enough to solve our entire polynomial, is it? So we're going to have to go back up here and use our last condition, p of 2 is equal to 2, and see what happens there. When we plug in p of 2, we get a times 2 squared plus b times 2 plus our c value, which is 1. So this gives us 2 squared is 4, and I'm going to put our integer out front, 4 times a plus 2 times b plus 1. We know that has to be equal to 2. So let's reduce this a little bit. 4a plus 2b, if we subtract 1 from both sides, we get 4a plus 2b is equal to 1. Now we have two equations here. We have a is equal to negative b, and 4a plus 2b is equal to 1. That's two equations and two unknowns, which means that we will be able to solve. Let's do a substitution. Let's put in negative b for a. Okay, so negative 4b plus 2b is equal to 1. Smush those together, we get negative 2b is equal to 1. Divide out both sides by a negative 2, and we have b is equal to negative 1/2. So there's our b value. Here's our c value. Last value, a is equal to negative b. A is equal to negative, our b is a negative 1/2. When we have the double negative, that turns into a positive. So our a is equal to 1/2, which means if we put this together, our polynomial is 1/2, so there's our a value, x squared, minus 1/2 x plus 1. And this is the only polynomial that satisfies all the conditions given. Isn't that nice? Thank you for listening.